Hello, my name is Gregory Manicherry, and today we're going to be talking about modern Formula One and competitive balance. Let's get started. Formula One has a long and rich history. Beginning in 1950, Formula One was kept alive by the love of motorsport and the thrill seekers. The sport was incredibly dangerous and often had multiple driver and bystander fatalities every year. In the 1970s, the cars were experimenting with extreme designs. The Tyrrell P34, for example, had 6 wheels. In 1978, Formula One began being televised. Throughout the 1980s, the sport grew globally, and sponsors came pouring in. Since the cost of racing is so high, sponsors are needed to help pay for research and development of the cars. Sponsors want to be associated with the best teams, obviously, and look to make their teams as competitive as possible. As sponsors realized how quickly the viewership of Formula One was growing, more and more money came in as sponsors would outbid each other for advertising space on the best cars. Sponsors wanting to be associated with winning teams left smaller teams ignored and ill-equipped to compete with more proficient cars that the higher budget and winning teams were building. This still happens today, where lower budget teams have empty space on their cars, and the top teams have barely any. Over the last decade, only Red Bull Racing and Mercedes-AMG Petronas have won the championship. This dominance is killing the viewership numbers for Formula One, as viewers get little to no utility watching the same teams constantly win. Now for competitive balance. Competitive balance in a sports league means that there is uncertainty of outcome. The more competitively balanced the league is, the more equal the chances of each team winning becomes. In the NBA, for example, with 2 teams competing, the perfectly competitive chance at winning is 50%. In Formula One, where multiple teams are competing at once, the competitive odds are slimmer. For example, with 10 teams in a season, the odds of winning given perfect competitiveness are 1/10 or 10%. Here's just some of the literature related to this topic. In Pay Dirt, Quirk and Fort outline competitive balance and how to test for it using idealized standard deviation and also distributions of actual and theoretical data, seeing how closely they align. Judd expresses how TV viewership is closely related to how uncertain the race outcome is. Factors like rain, for example, always draw a higher viewership. Rule changes to keep teams innovating keeps a level of uncertainty higher and maximizes television revenues and sponsorship exposure, keeping those who run the show happy. Schreier also comments on the importance of uncertainty and overall higher TV demand. The null hypothesis being tested is Formula One was competitively balanced over the last 20 years, and our alternative hypothesis is that Formula One was not competitively balanced over the last 20 years. So let's see what happened. Utilizing idealized standard deviation found in Pay Dirt, we can judge how balanced the Formula One league is by doing as follows. First, we find the actual standard deviation from the data. Then we find the ideal standard deviation by using the number of competing teams and the number of races in the given season as such. For example, with 10 teams, a 16-race season, the idealized win percentage standard deviation would be 10% divided by the square root of the number of races, resulting in 0.025. The ratio of actual win percentage standard deviation from the data and the ideal win percentage standard deviation of a perfectly competitive league is 1. The closer to 1 we get from our data, the more competitive the league. Distribution graphing is also used. By plotting the data as well as a normal distribution showing the perfect competitive scenario, how close a league is to competitively balanced can be observed. In the case of Formula One, with constantly changing race calendars and numbers of teams, the graph for all 20 years is an estimation. 4 of those years, however, had directly comparable data, and a more precise graph is also shown for these years. The data for these tests comes from the Federación Internazionale di Automobili, or the FIA. They are the governing body over many international motorsport leagues, including Formula One and World Rallycross. They are also the record keepers for these motorsport leagues. Here is a small piece of data table 1. In this table, broken down by year, there are the teams who won races, their respective win percentages, total races in that season, the number of teams competing, and the perfectly competitive win percentage for a league of that many teams. The full table can be found in the appendix of my paper. Teams that did not win at least one race are not listed here, but were taken into consideration during calculations. Here's a snippet of Table 2, showing again by year the range of the win percentage of the winningest team to the least winning team, the actual standard deviation from the data, the idealized win percentage standard deviation taking into account the number of teams per season, and the ratio of the actual and ideal win percentage. This ratio is what should be close to 1 and already begins to paint the picture of what is to come. The full table is again in the paper. From Table 2, the average ratio of actual to ideal win percentage standard deviation for all 20 years is 8.324. This is extremely high and suggests that Formula One is not competitive in the slightest. The NFL, in comparison, has an average ratio of 1.66 from its inception to 1990. It is not looking well for the competitiveness in F1. Here is Figure 1. This is an estimation of the normal distribution of wins given that there were varying numbers of teams and races per season with no areas of overlap to compare. 69.9% of the teams from 2000 to 2019 never had a single winned race. Hence the spike in the blue line drawn in the data. Clearly, the actual data is not even close to normally distributed, with very few data values falling within 1 standard deviation. Figure 2 shows those 4 years with comparable data. These years were 2000, 2001, 2002, and 2007. It is also clear here that many teams participating in Formula One during this time never won a race. In fact, it was 77% of the competing teams. The null hypothesis is therefore rejected, and we accept the alternative hypothesis that F1 is not competitively balanced. The actual to ideal win percentage standard deviation ratio is far too high, and with the data being as skewed as it is, there is no argument here for competitiveness. So what does this mean for Formula One? Formula One has become the most extreme advertising marketplace. It only sustains itself from the contributions of its sponsors. For those sponsors to stay incentivized to keep advertising on the cars, more competitiveness needs to be introduced to keep viewership high. Formula One will not survive if viewership declines, and the FIA knows this. Beginning in 2021, budget caps of $145 million will be enforced on performance spending. Salaries, safety measures, and other things are not included in this budget cap. $145 million is 1/3 of some of the larger successful team budgets, and it would be an interesting year to spectate and study. Here are some of the references for this research. And here is Daniel Ricciardo doing a shoey. Thank you so much for watching.